Now we've started. Right, so I've already written this. This was, yes, this is a shambolic start to this particular video. Let's pretend it didn't happen. So question 7 on the Core 1 Summer 2008 paper was an inequalities question with 2 little twists in it. The first one is that this is just a straightforward linear inequality, just a straight line expression. But it has 2 sides to the inequality. And we don't get confused by this, we don't get distracted by it. All we do is just carry out the same operations, but make sure we do them to all 3 portions of it. So whereas with an equation, if you were going to add 2 to both sides, you'd add 2 to both sides. Now we're adding 2, but we're doing it to all 3 sections. So our first step is going to be to add 2. And there's no great mystery to it. All we're doing is we're adding 2 to each bit. I'm going to change that so it looks less like the number 16. There we go. So we just get that. And then the next logical thing that we would do would be, if this was just 3x on its own is less than 13, you'd divide by 3. So we'll do that. And that's it. We've solved the inequality. That's all we had to do. We just have to say that x is bigger than 10 over 3 and less than 13 over 3. And there is your 3 marks just for doing that. Part 2. Again, it's a really standard inequalities question, but with a twist. And I've already mentioned this, that when you have a quadratic and the 3rd term, the number term, is missing, then people often get thrown by it. What we would want to do, what we'd always want to do with a quadratic inequality, is we would want to work out where it crosses the x-axis. I would call those the critical values, the points where it crosses the axis, so in this case the y-axis. So the first thing to do is to factorise it. We're not going to be distracted by the lack of a number term. We're just going to say what we'll do is we'll take out a common factor if there is one, and there is a y. So that factorises like that. So the critical values in this expression, the points where this gets really interesting, are when y is 0 and y is minus 2. And we're kind of in our mind, we're pretending that this is all in terms of x, and we're just thinking, what does that mean in terms of the graph? You've got a graph that crosses at 0 and minus 2, so 0 and minus 2. I don't know why there's a slight wiggle in the board, but anyway. So we've got those 2 points, and we wanted to know when was it bigger than 0. And it's bigger than 0 over here, when we're less than minus 2. There it's bigger than 0, there it's bigger than 0. So the region that we want are those 2 regions there. We're going to say y less than or equal to minus 2, y bigger than or equal to 0. And that was our 4 marks for doing that. I really think that when you're dealing with quadratic inequalities, the safe way to do it is to draw a little sketch of the graph so that you can see when it's above or beneath the relevant axis. And there we go.